Physics 101 Dynamics homework, question number 12. We have a block of wood of a known mass. We are given the mass in the problem. So if we know the mass, then we also know its weight. So the force of gravity is its weight. That's going to equal its mass times g. Now, if I look at this carefully, I see that it is not accelerating up or down. If it's not accelerating up or down, then F net is going to be 0 in the y direction, which means whatever forces are down have to be negated by forces up, and the only force that could possibly be up in this case is the normal force. So in this one, now not always, but on a flat surface, when there's no other forces involved, then the normal force is going to end up equaling the gravitational force. That's important for this problem because we're also given the coefficients of static and kinetic friction. And it says, what is the frictional force? So state the force of friction that's applied to the block by the ground at time 0 and greater than 0. Okay, so we're going to have to figure out a couple things. We're going to have to figure out the maximum static friction, because if we're pushing harder than the maximum static friction, it's going to start to slide. If we're pushing less than the maximum static friction, then the frictional force will be sufficient. There's going to be enough frictional force, static friction, to stop it from moving. So we're going to have to figure out Fs max, the maximum static friction, and that's going to equal mu s times Fn, the normal force. I just told you how to figure out the normal force. Mu s is given in the problem, so you can figure out Fs max. Now, I have an applied force. In my problem, it's given right here. I don't know what your number is. That's the number that it gave to me. If that number is less than the maximum static friction, then the frictional force will be equal to whatever the applied force is, because it won't accelerate. It's not going to start sliding if the applied force is less than the maximum static friction. So there will be a frictional force that's going to be equal to my applied force. If my applied force is bigger than the maximum static friction, then the most frictional force that can be applied, the maximum that can be applied, is the maximum static friction. So that would be what the force would be if I'm pushing harder than the max static friction. It would either be whatever I'm applying or whatever the max static friction is. That's at time equals 0. For both of these, actually, whether I'm applying a small force or a larger force. At time greater than 0, if I applied a force less than the maximum static friction, and it's not going to start moving, and the frictional force is going to stay whatever I applied. If I applied a force bigger than the maximum static friction at time greater than 0, it's going to start sliding, and the frictional force will equal the kinetic friction. And you calculate kinetic friction, the force of kinetic friction, with mu k times normal force. All right, that should get you going on that problem.